Radioactive Food Preservation Techniques by Nick Skillen. Food irradiation. To preserve the safety and amount of food that's exported daily throughout the world, chemistry techniques are used to efficiently treat food and prevent it from spoiling. Modern nuclear chemistry is used to kill bacteria and other microorganisms that cause the food to spoil. Food irradiation is the process of exposing a food source to ionizing radiation using either X-rays or gamma rays to kill off microorganisms. Ionizing radiation is created by atoms concentrated in the forms of waves that remove an electron from the atomic nucleus of another atom. These waves are categorized on the electromagnetic spectrum from high frequency or to low frequency, or high energy to low energy, as you can see below. High frequency waves, such as radioactive cobalt-60 gamma waves with a frequency of 1 × 10 to the 18th Hertz, are more efficiently able to penetrate through substances, such as food, than waves with less frequency to rid the product of microorganisms that cause the food to spoil. Radioactive cobalt-60 gamma rays. Cobalt-60 is a radioactive isotope used as a radiation source for food irradiation. What does radioactive mean? A material that spontaneously emits radiation of alpha particles, beta particles, or gamma rays is radioactive. Cobalt-60 emits gamma rays, which is the strongest form of radioactivity discovered. Shielding from gamma rays requires large amounts of mass to block the ray's penetration, in contrast to alpha particles, which can be shielded by even paper or skin. Beta particles can penetrate stronger materials than alpha particles, but can still be shielded by even aluminum foil. These penetration differences between the types of radioactive decay judge the strength and uses of radiation. Alpha particles. Alpha decay is a type of radioactive decay where an atomic nucleus emits alpha particles. In alpha radioactive decay, the product in the reaction has a mass number that decreases by 4, and atomic number decreases by 2. For example, when uranium-236 radioactively decays to form thorium-234, the mass number, which is the total number of protons and neutrons, of 238 decreases to 234, due to 2 protons and 2 neutrons leaving the nucleus. The atomic number, which is the total number of protons for uranium, of 92, also decreases to 90, because 2 protons left uranium's nucleus. Energy is lost into the system during this process due to the parent radionuclide transforming into a daughter nuclide with a different number of protons and neutrons. This binding energy is the energy needed to separate alpha particles from the original nucleus. Beta particles. Beta particles are high-energy electrons or positrons removed from an atom's nucleus. These particles emitted are a form of ionizing radiation because electrons or positrons, which are opposite antimatter of electrons with a positive 1 charge, are being removed from the atom. These are 2 types of beta particle decay, or there are 2 types of beta particle decay, beta minus decay and beta plus decay. Beta minus decay is a type of ionizing radiation where electrons are being emitted from the atomic nucleus. Before the electron can be emitted from the atom, a neutron decays into a proton, an electron, and an antineutrino. Then the electron and the antineutrino are emitted from the atom, but the proton remains in the atom's atomic nucleus. Beta plus decay is a type of radioactive decay where positrons and an electron neutrino are released from the atomic nucleus. Overall, both forms of beta decay are radioactive due to their ionizing electrons or positrons separating from their atomic nucleus. In summary, with today's modern scientific methods to preserve food and make day-to-day life easier, concern about using food preservation techniques involving nuclear chemistry has appeared. Minor misconceptions regarding sending radioactive isotopes such as cobalt-60 gamma rays through food to kill microorganisms has been criticized, yet the true science of the matter proves that radiation from gamma rays passes through the substance being sterilized. Therefore, little or no radioactive waste would remain in the food. As society's technology advances in the future, food preservation techniques will also continue to improve, and criticisms will be minimalized due to more efficient methods to preserve food. Citations.